Alright guys, back again today with another video. Now last video we ended off by saying that voltage doesn't just exist at the battery, because the charges are carrying the potential, right? They're carrying the voltage. And the same can also be said for the wire. Let me explain. So let's say we've got a point A, right? We've also got a point B. And these are all points along a wire. And we try to compare the voltage of these different points. So we find that, let's just say, for example, that point A has 10 volts and point B has 5 volts. So you could say that in between these 2 points, there's a difference in potential, right? Because look, there's a difference in voltage measure, there's a difference in electric potential. It goes from 10 volts to 5 volts. You could also say that there is a change in potential. Because it changed, man. Because in order for the charge to go from A to B, it had to go from 10 volts to 5 volts. So you could say that, yes, there is a difference in potential between these 2 points. And because these points are on a wire, obviously, in between these 2 points, there's wire, right? There's at least a tiny bit of segment of wire in between those 2 points. And because there's a difference in potential in between the points, there's also a difference in potential in the wire. There's a voltage difference in the segment in the wire. So at the wire, as we just saw in the example a while ago, the voltage difference of that example was 5 volts. So I bring this up because we are going to introduce a topic known as potential difference. And there's also a saying that voltage stays the same at any point in the wire. And you might be thinking, that kind of contradicts what you taught us a while ago, right? Because, a while ago or last video, I taught you guys that voltage of the charges going through a wire will drop, right? It starts at the battery, and along further it goes, the voltage drops. So why is this saying true? Well, really, what this saying is trying to say is that the difference in voltage stays the same at any point in the wire. Now, to fully explain this, let's try to use the MOBA carries analogy again. So let's say we want to compare a carry at the start of the game versus 5 minutes in the game. So at the start of the game and at 5 minutes of the game, we'll try to see, okay, what's the difference, At the start, the carry has done nothing, 0 kills, 0 damage, they've used none of their potential at all. But 5 minutes into the game, they've already got 1 kill. And you can say that, they've used a little bit of their potential. You could say, or you could clearly see, that there's a difference in potential, right? Because, they use their potential to reach that point. But let's try to actually measure it. Like, what exactly is this change in potential? How do we concretely measure this change in potential in between these 2 carries? So let's just say, for example, we try to understand, so the carry at the start of the game, he has no items, man. He has just like a cookie or something. But the carry 5 minutes into the game, he's already got Bloodthirster, and he's already bought a first item. So we can say that the difference between these 2 carries is that one of them bought an item. The difference in potential is that they bought an item. In order for the carry to reach the point of the 5 minutes, they had to buy an item. The difference in potential is buying an item. Let's try another example. Let's say we want to compare a carry 5 minutes into the game versus a carry that's 10 minutes into the game. Again, we'll try to look what makes them different. And we see that, 5 minutes into the game, they've got 1 kill. But later on at 10 minutes, you can see, they've already got 4 more kills. They got 5 kills now and they've done more damage. So again, let's try to see what exactly is this difference in potential nila. 5 minutes, we already know that they bought 1 item, right? But at 10 minutes, we see that, they bought Infinity Edge, so they bought 1 more item. So again, the difference in potential in between these 2 carries is that they bought another item. And the same can be said for charges. Let's try to compare a charge at the very start versus a charge later on. So you can see that there's a difference in potential between these 2 points, right? In order for the charge to go from 10 to 8, its difference in potential was 2 volts. It had to use 2 volts to get to that point. You could say that their potential difference is 2 volts. And in between these charges, you could say that the potential difference of the wire in between these charges of the segment of wire is 2 volts. Let's try another example. Let's compare from 5 volts to 3 volts. What's the change in potential? 2 volts. So you could say that the amount of volts that the charge had to use in order to get to the new point was 2 volts. Now, the same can also be said at just a point in the wire. A while ago, these examples were just segments in the wire, right? There were spaces in between these charges, There was space from the 5 volts to 3 volts. But the same can also be said for just one tiny point in the wire. Let's say we want to take a look at the voltage difference at this point in the wire. See this very tiny dot? And we'll say that, the charges at the charge at the very left of this point just so happens to be like 8.54 volts. But at the right, it's 8.61 volts. Actually, wait, sorry, that's supposed to be the other way around. But anyway, we see that the voltage difference of those two, of that point, the voltage difference in between those two charges, the voltage difference at this one point in the wire is 0.07 volts. And it'll be the exact same thing no matter what point you measure in the wire. It could be here or it could be here. Side note, difference of potential will only stay the same if you measure the segment of your wire is also the same length. Like for example, you get the voltage difference here, dinhidapit sa wire, and you also get the voltage difference here's a wire. So because they're the same length, obviously they're going to have the same difference of potential, right? But let's say you measure this very tiny segment, but then you also measure this really long segment. So obviously they're not going to have the same difference of potential because this wire is way smaller, but this segment is way longer. So keep that in mind. So in conclusion, you could define voltage as the electric potential. It is the potential of charges to do something or just to move along an electric circuit or an electric field. And the change in potential, the difference in potential, whatever you want to call it, it's just the difference in voltage between two charges or two different points in a wire. You could also say that the change in potential is the amount of potential that a charge had to use, to unlock, to achieve, the amount it had to drop or change, whatever word you want to use. But basta, the amount of potential they had to change in order to reach a new point. Now, the reason why I brought up this topic is because later on, when we get to the topic of parallel circuits or series circuits, you're going to wonder why is it that sometimes they'll say that the voltage is just the same across the wire. Later on, you'll see something like that, and this understanding is going to better help you understand that later on.